All right, so the other day we did simplifying radicals, leaving them in as a radical form so we didn't have a bunch of decimals. All right, so this section is going to cover how to multiply. All right, we're going to multiply, and then I'll make a different video how to add radicals, but it's a lot of the same concept as just simplifying the radicals and then combining them or adding them or multiplying them, however we want to think about it. So in the previous section, we talked about there was a algebraic thing that said the square root of AB equals the square root of A times the square root of B. So that basically means if you have two radicals that are being multiplied together, you can think of it as just one whole radical, all right? Conversely, too, if you have one whole number, we can think of it as two separate ones, which is how we get to simplifying. So we have a whole number on the outside of a radical and something left over on the inside. And we were doing that with prime factorization. All right, so on the previous section, when we were reducing the radicals here, we talked about, hey, look for your doubles and then take it out so we would have a final answer that looks something like that, right? So we spent a day on that, and this is basically the same kind of idea, but we're just now have multiple radicals that we're multiplying together. Now I think the easiest way that we can do this is step one, putting them under one radical symbol, but don't multiply them together. Let's keep them split up. And then we're just going to do the prime factorization of each separate number. All right, so step two is break down all numbers by prime factorization. And then again, we take out the pairs to simplify the radical. So if I think of it like this, I have 15 and I have a 10 underneath. So I'm going to break down these to 2 and 5. Break down this to 3 and 5. And then we look for our pairs. So our prime factorization of 15 times 10, which would be 150, is 2 times 3 times 5 times 5. Now I'm just listing them in order so we can see our pairs next to each other. So look for your pairs that you have. In this case, we have a pair of 5s. All right, so I'm going to circle that pair. That pair comes out. So the 5 comes out. There's no other pairs that are left inside the radical. So we have 2 times 3, which is 6, inside the radical, and that's it. That's our final answer. 5 times the square root of 6. All right, so the same idea here. And again, even if there's variables or anything else, we're just listing the variables out. We're just looking for pairs of numbers that will come out of that radical. So if I want to think of it like this, the square root of 8 times 12, and I'm going to do my prime factorization of both 8 and 12. 2 and 4, 2 and 2, 12 we have 2 and 6, 2 and 3, and now look at all of your end numbers in here. So I'm going to rewrite this in order. I have 1, 2, 3, 4, 5 2s. 1, 2, 3, 4, 5, and a 3. All right, so where are my pairs of numbers? I have a 1, 2, another pair of 2s, all right? So I can take 2 2s out. So that would be 2 times 2 on the outside with 2 times 3 on the inside. 2 times 2 is 4. 2 times 3 is 6. All right, and this works if you're multiplying, just more than 2 together. You can multiply 3, 4. It doesn't matter. We can always fit them underneath the same radical symbol. But that's how you simplify it, and it kind of does, does the work for you. The other way to do it would be to multiply 10 and 150 together and call it the square root of 150, and then you break it down from there. But again, your first breakup can be 15 and 10, and then you're going to end up with this anyway. So I look at it as if you're doing a factor tree of the bigger number, they already kind of split up the first two factors for you. So just do those little factors and look for those pairs to take them out.